Okay, your second example for how do I use, or really your third example, I guess we count 16. How do I prove other things by using congruent triangles, but specifically, how do I use CP/CTC in a proof? Okay, and I said you can prove segments or angles congruent using CP/CTC after you've proved triangles congruent. But if you look at 18, I'm not asked to prove segments or angles are congruent. I'm actually asked to prove that lines are parallel. ML is parallel to WQ. Okay, so maybe a little bit of working backwards here would help us out. Recall chapter 3, proving lines parallel. Of course, we had 6 ways to do that. Bottom half of your purple DPPT sheet. If you want to reference that, take a quick look, but we're ultimately thinking angle pairs. If I have one of my specific angle pairs congruent, then I know lines are parallel. Okay, that's the key right there. Okay, and I'm just going to look right now. ML parallel to WQ. Well, let's take a look. To prove ML parallel to WQ, of course, I have 3 possible transversals. I'm going to look at that diagonal one. Can you agree with me that if I knew those 2 angles were congruent, then I would know that the lines are parallel to each other? Are those corresponding angles in my 2 triangles that I have within that figure? Yes, they are. Okay, I hope you're kind of seeing sort of what I'm going for here, that we're going to be proving angle. I'm going to be proving triangles congruent. I'm just going to do sort of a general here so that I can then prove those angles congruent so that I can then prove lines parallel to each other. Okay, so the other proof, we stopped right here at 1 step after triangles congruent. I'm going to go 2 steps after triangles congruent in this proof. Okay, I'll walk you through it. First thing that we have to do is ultimately prove triangles congruent. I just wanted to give you the goal. I'm going to separate my givens. I'm going to work off of, I'm going to temporarily kind of ignore that. I'm going to work off of my given MQ parallel to WL. And hopefully you can like reverse what I was just showing you with the other parallel lines, or the lines I'm trying to prove parallel. Can you find an angle pair that would be congruent based on those lines being parallel? That's the one I'm seeing. Okay, you can use 3 letters. You can go ahead and put angles, angle numbers in the corner just for the sake of simplicity. I'm exhausted. I'm going to go ahead and put numbers here and call those angles 1 and 2 and say, hey, I do know that angle 1 and 2 are congruent, and that would be based off of lines being parallel, particularly alternate interior angles in my picture. Okay, excellent. I've got 1 pair of angles congruent. I need 3 pairs of congruences before I can say triangles are congruent, so there we go. I've got 1. Good news, when I look at step 3, or really when I look at my other given, you might have had it at the top. I'm told segments are congruent. MQ is congruent to WL. Sweet, I don't have to do anything. It's already given to me. I love it when that happens. So I've got a pair of sides, a pair of angles. Whoops. I have done way too many proofs at this point. Okay, there we go. Hopefully you're checking my work. I've got one more thing that I have to say is congruent. And go back to day 1, shortcuts. Look at your picture. Okay, I use my given information. I'm out of given stuff to work from. What's there that I'm missing? Vertical angles are a good thing to look for. Shared sides are a good thing to look for. And in this case, I am seeing that shared side in the middle there, part of both triangles. So what's that going to look like in my proof? That's going to be me stating that QL is congruent to QL. Remember, we have to state it, even though it seems obvious because I have to have my 3 congruent statements. And that's my reflexive property. So I now have angle, side, and I have a second pair of sides congruent. Okay, it looks like I'm ready to go ahead and say triangles are congruent. So I'm going to bump this up, but I guess I need to actually write them out. Triangle, what? Can we put a name with that? Triangle, you get to pick for the first one. Give it any name that you want. I'm going to say QML. And all you got to do is make sure the second one matches. So angle Q in my left-hand triangle matches up with, well, that has the arc mark, matches up with angle L in my other triangle. M, well, QM matches up with LW. And then I'm going to finish that off with Q. Okay, just make sure you're matching up corresponding parts there. Check angles, check sides. Okay, the order does matter there. That's something I'm going to look for when I'm grading these proofs. Look at your shortcut. Again, I've got ASS if I'm looking on the left-hand side where I've noted my angles and sides, but that's not important. We're looking at the picture. Please note that this is the order I'm looking for. I'm looking at sides coming together. Is that the angle that's marked congruent? Sure is. So that's giving me shortcut of included angle, side angle, side. Okay, all the way up through step 5. That's just like any one of those 8 through 15 that you did on your worksheet that you should be getting pretty good at this point. Here's where it gets different. This is the new part for today. I've got to use that to prove the fact that triangles are congruent to prove lines parallel. And I know that to prove lines parallel, I need to have angles congruent. So I'm now going to say that because the triangles are congruent, okay, I have in my picture, I'm going to clean things up a little bit in my picture. So it looks like things are getting a little messy. I call that 1 and 2. And I have so far stated those are congruent, these are congruent, and angles are congruent. But as soon as I say what I said in step 5, I now know everything in my triangle, not everything, all the corresponding pairs of angles and sides are congruent. So I'm going to go back to my picture. I'm going to say, wait a second, I now know that those sides are congruent. I now know these angles are congruent. And for that matter, I know that. I could state any one of those. What's going to help me to prove that the lines are parallel? And this I kind of prompted you for at the beginning. It's going to be using these two angles, which I'm going to number just for simplicity, 3 and 4. If I can say angle 3 is congruent to angle 4 by, this is your new one, corresponding parts of congruent triangles are congruent, then I can say that the lines are parallel to each other. Okay, again, that's my top and bottom there. Because those are alternate interior angles, and it's going to become my be careful, make sure you're using converse. Yes, they're alternate interior angles, but I switched it. Okay, beginning of the proof. I love this proof because it's a great review of chapter 3. Beginning of the proof, step 1. Lines are parallel, so angles are congruent, alternate interior angle theorem. Ending of my proof, angles are congruent, therefore lines are parallel, alternate interior converse. These last 2 steps are really the new part of what we just did. Everything else was review. Okay, but I wanted to show you how you could definitely add 1 step to your proof after proving triangles congruent, which we did on Thursday. Add 1 step. Corresponding parts of congruent triangles are congruent to say either sides or angles are congruent. And then possibly add another step. Based on knowing angles are congruent, prove lines parallel. Based on knowing segments are congruent, perhaps you could prove something's a midpoint. Okay, and you're going to get a little practice with that as you work through the homework worksheet. Go ahead and start on it now.